Cool. Yeah, we hear you, disembodied voice. Thanks. All righty. So, uh, first off, let's see. Is there anything you all have questions about? I think the web work has closed, so maybe not. But if I just, if there's anything you want to talk about, let me know. I've got a plan. I got some warm-ups to get us rolling. Cool. All right. It doesn't sound like it. And if at any point along the way you got a question, chime in, DM me, and we'll definitely address whatever you got. So we are going to start something new today, but we're gonna enhance what we've been working on. So remember, what we've been working on is substitution and integration. So integration by substitution would be a better title. I was going to introduce you to my little pug baby, my pug daughter, but she's not in here right now, but maybe she'll pop in during class. But she's too adorable to not show you. So look at that handwriting. Looks like I ride a bike while I write. Good Lord. Okay, cool. Warm up. Please do this integral. Using substitution. Might be other ways to do it, but they're probably horrible. Let's see, somebody else just showed up here. Maybe not. Oh, is that you? Okay, Gabe. That's it. Because I was like, I thought Gabe was here before. That sucks. I'm sorry to hear that. That's frustrating. Hopefully it'll remain stable for a while. But just pop back in if you get dumped out. If just to make sure you are on the right track, you want to be letting u equal the thing inside the parentheses. If you didn't do that, you're probably in a world of hurt. Things aren't working out well. Ooh, I hear a pug at my door. I'll be right back. Come on in. Come on in. Want to see my students? Oh, okay. Didn't want to come in. Okay. All right. Well, false alarm. Whoa. Silly me. There was a 2 there. All right, so still working. Cool. If you're done, check yourselves out. You could have found an error in mine just a few moments ago because I forgot to bring that 2 out in front that came from the differential change. I forgot to bring that out. And then you get a -1 out in front because of the power rule. And then when you back substitute, you get this little thing over here. Is there anything you'd like to talk about in that problem? Any questions or anything like that? Got a chat. Oh, let me see here. Yeah, it's easy to forget that C. Absolutely. Good news is mostly not a problem. If we have some specific values, well, actually, yeah, I'll do an example, Abraham, where having the plus C is kind of essential for us, but overall, it's like, yeah, if you can do this, that's the heart of it all. So you're in good shape. Anything else to chat about here? No. All right. So let's do one more. Let's see. Okay. Let's do this one. This is kind of one of my favorite ones, and we have to do this. Like everyone who comes through Calc 2 with me, we have to do this. Crazy looking. Here's my tip. Use the E form, right? You see an E. Anytime you see an E in an integral, I would go for that form first. So this one actually ends up being pretty simple, even though it looks pretty nutty. Yes, that is totally right, John. Just got a little message from John, and he was just asking about what we're going to let U be. So let's talk about that together. So I've got this E thing here. One of the E's has a messy exponent. I want to clean that up. Substitution's all about kind of sweeping things under the rug to make things look prettier. I also know this form over here. This is really the only thing I know how to integrate in terms of E. And the antiderivative of E to the U is just E to the U. So that's going to guide my hand in making the substitution. I'm going to lay that template over the top, and I see that that is the thing that appears inside the U spot. So like imagine that E to the U du, this form here being kind of transparent, and I lay it on top of this, and what comes through the U window is that E to the X. So I go for that. So I'm going to let U equal E to the X. And then if from here, it's just mechanical. And I'm going to solve now. So that's step one. Make the U, find the differential change, and then solve for dx. And I get dx is du over e to the x. And now I make that substitution. I rewrite the whole integral. And then this e to the x is still there, but I see that things were working out in my favor because I get to divide that e to the x out. And remember, if you have x's and u's at this stage and they're not canceling completely the x stuff, then you've done the wrong substitution. You need to go back and try a different one. Or maybe you just can't do it by substitution. So then this becomes just integral of e to the u du. That's lovely. That's literally just e to the u plus c. Now I'm just using the formula. There's no constants or anything popping out in front. So then I back substitute, and I get e to the whatever u was, which was just e to the x. And I tack on my plus c. So it's weird.
I have a question.
Yeah.
So when you're substituting u for e to the x, you don't have to switch it in for every instance of e to the x? Like you don't have to swap that second one for u as well?
Yeah, that's a great question, Abraham. So in a substitution, generally, we're going to substitute one instance for u. So like you decide what u is going to be. And I would say in general, just replace that single thing that caught your eye with u by u.
Okay, because I thought you had to switch every instance of that specific thing. Okay.
No, and if I did that, let's take a look at that really quick. So if I did that, and I did that, so I get e to the u, and then this would be u here. Now when I come in and I do the differential change, so I still have to replace the dx with something du. Well, maybe, I guess this could work out, actually. I think it could get confusing. I think this could work out. So let's see here. So we go e to the u, u, and then dx is this. So I'm going to replace that with du over e to the x. And as long as I remember that e to the x is u, that this thing here is actually my u, then I could cancel those. Otherwise, I could be a little confused because I've got that e to the x and it wouldn't cancel with anything. But it could work out. So, cool. Any other questions on this one? I have a special visitor I need to introduce you to. Meet my friends. These are my calculus friends. This is my pug daughter, Maple, right here. Hey, Rosie. Her name's actually Maple Rose, but She does calculus. We do calculus. Okay, let's go back to bed. There you go. All right. One more problem. One more one. And I'm not going to leave you too long in thinking that substitution will solve this problem, because we can't do it with substitution. And just maybe prove that to yourself. Just convince yourself that substitution cannot work in this problem. Because that's really what this one's about, seeing that. Silly me. What a silly fellow. All right, let's group back up. So I have a fraction, and if you remember, we talked about different ways to attack fractions with substitution. There's no parentheses, so what I suggested was let u be the whole denominator. If there's no parentheses in a fraction, that's always a first good move. If we do that, if I let u equal x squared plus 1, then du is 2x dx. And when I solve for dx, I get dx needs to be replaced with du over 2x. When I come to do that, so I replace the x squared plus 1 with u, I replace the dx with du over 2x. Notice that there is this 2x, this x can't be canceled. The 2 is not the problem. The x is the problem. Every variable has to cancel. That 2 would come out in front, but the x doesn't cancel. So this is not going to work. So you might say, oh, let's try something a little simpler. You might try let u equal x. Well, that just rewrites the whole integral in terms of u, and you just get this. And that doesn't really help us. So, and in fact, that's never a good, unless you like writing stuff, you'll just be rewriting the problem. That never is a good idea. Does anyone know how to do this one? Because it's actually a formula. Does anybody recall this formula? Let's get our integral table out. I'm going to get that. So I'm going to go to world class. And I'm going to get, why do I have to log back in? Don't make me do that. Okay. So I go to world class, I grab our table, and I'll pop it into the message window here for us. I go to content. And if you haven't checked this thing out,
one, isn't it?
What's that? Oh,
is it the arctangent one?
Yes, it is.
Oh, yeah.
Solid. Yeah, absolutely. And yeah, beautiful. I want everybody else to see that on the table. So let me grab the ultimate calc reference sheet. Let me download it. That is absolutely right, though, Abraham. Let's see. I'm going to throw this in the chat window. And yes, and then John's also saying that. And so is Jeremy. Beautiful. And then, oh man, other folks. Oh, exciting. Look at all the folks. Look at all the folks chiming in on that. Yeah, I'm not getting notifications for some reason, but let's see. I'll toss this into the chat window. So let me do that to everyone in the meeting. Send that out. Cool. So that should be in the chat for you if you want to pop that open so we can all just look at it. Let's say you didn't know that. Let's say you didn't know that this was the arctangent form. So you would go to your table and you would roll down to page 6. And that's where the integrals start anyway. And I keep cruising. I don't see anything that quite looks like this. What I'm looking for is a form that has something with a u squared plus a constant in the denominator. I'm looking for something like that. And I have to go, notice how they have them nicely organized here. Their forms, the major part of it is the clumping here. And we got to go all the way down to, shit, where the hell is it? Why am I not finding it? Maybe somebody can help me. What formula number is it? It should be like, it is just arctan. Why the hell isn't the arctan just so obvious on here? Am I convincing myself? Like, am I like, it's this? It's not. Someone, John just said you're not seeing the reference sheet. Is that not popping through the? Are you all not getting that? Damn.
I can see it.
Okay. Cool. Yeah, check again. Maybe it's just taking a little bit to come through. But I'm a little disappointed that I'm having such trouble finding the arc trig forms in this table. Dude, that is ridiculous. Oh, here, wait. Somebody's John, you found it. Page 5. Yeah, they do have it in the derivative form. I was kind of hoping to have it in. Oh, cool. Okay, yeah, check out formula 17 on page 6. There we go. I don't know why I wasn't seeing that. So formula 17 on page 6 says this. Integral du over a squared plus u squared equals 1 over a arctan of u over a. So even if I don't know what an arctangent is, And that's pretty much the state of the world today. Very few people actually know what an arctan is. Hopefully you'll know a little bit more by the end of this class. But think about what we had. We had this. So I'm kind of talking about how to use this table. Notice the rhythm in the formula. It's a constant. A squared is just a constant. And u squared is the variable. And it's the variable pattern that you're really looking for. So here we have variable squared plus constant in the denominator. And that's an arctan. So syncing this up, I'm just going to rewrite what we have a little bit. So that's actually 1 squared plus x squared dx. And now when I lay that table over, I see that a would have to be 1 and u would have to be x. And that makes life real good because then I can just go and use this formula. So I just get 1 over 1 because a is 1 arctan of arctan of x over 1 plus c. And I don't have to write all those over 1s. This is the real pretty answer. Ooh, I'm making that sloppy. Say pretty and then make it really sloppy. That's not cool. I don't like that notation, and I think I said that before. I like this. I think it's just clearer. You can do whatever you want as long as it's clear and then you understand what you're doing. So while we're on this formula, let's talk about it just a little bit more. And I am recording all of this, and I'll put this up on YouTube for us. But what if we had this problem? Let's see, what was the point? Let's try to make things a little. So check that out. Now I've replaced, now there's not a 1 plus x squared, but I have a 7 plus x squared. Let's look at that formula again. The formula says this. So looking at this, I've got the constant plus x squared in the denominator. Feels a lot like this. This thing here would have to be the a squared. So that means that a, that's that's like my arrow. That means so, or it follows that. A would have to be square root of 7. So then, now I can use this formula. So this is just 1 over square root of 7 arctan of x, and here I'm just letting u be x. Nice simple thing there, square root of 7 plus c. So this table can really be great. And a lot of times that it's literally the only way you can do some things. And there's some things in here you could do without the table, and they've used techniques that we're going to learn to do them, but they've got them all nicely pre-done for you. So everything's really good. All right, let me stop there. I've just been going off having fun. Is there anything here you'd like to talk about? It was unclear. Need to discuss. All right. It's like an auction. I'm watching for little moves in your faces and then like bigger moves in the chat window. All righty. So let's talk about a different problem. So let's say I asked you to find this integral, this antiderivative. So I've got x times e to the x. So one of the things I'm going to start asking you to do, and I'm going to recommend you do just whenever you're doing math, read the thing to yourself in your head. Say it to yourself. And be really precise and concise about how you say it. So when I read this, I read x times e to the x. You might just look at it and go x e to the x. what is that part in the middle? It's the times. So here we have, and I'm going to say it, x times e to the x. This times is a key. And this tells me that something needs to happen. It's a key to use what we're going to learn next. And I'm going to just give you the title of it right here, integration by parts. Let's first convince ourselves we can't do this with the things we know. And so I'll help us convince ourselves of that. So I can't use substitution. That's like substitution should be your go-to. That's like the very first thing you hope you can use substitution, because that's like, I mean, it's not easy, but it's less involved than a lot of these other things we're going to learn. So, I mean, what could this be? Well, I've got an E thing there, right? And the only thing I know how to do is that. And so u would have to be the exponent x, and then du is dx. And all that does for me is rewrite the damn problem like this. I didn't get anywhere. Still the same rhythm. Still is u times e to the u. There's nothing here that can work, and you could try a few other things, but they're all going to end up in failure. So then I think, okay, what other techniques do I know? Well, I read this as x times e to the x. I can integrate x. That's easy. I can do this. That's easy. The first one's power rule, second one's just e to the x. So that means I need to use integration by parts. If I see a product of things in there and each piece is actually simple without the product, like on its own, then this is what we want to do. So let me first show you how we're going to get a formula. You don't need to remember how to get the formula, but I don't feel good just giving you a formula. That's not a cool way to be. So this is our next technique. And I will note that there is a new web work that will open up after class. So it's web work 2, and it's on this technique. And it would be really cool if you could at least look at it before Friday. In fact, Friday, we might just, how about on Friday, bring your laptops to class and we'll work together on that web work, because I've got more web works to give you. There's no shortage of web works. I'm not worried that we'll get this web work done and you won't have anything to do. I'll take care of you. I got you. So integration by parts. First off, let's just notice some things. Oh my God, when a mathematician says notice, you know you're in for something. And that is what's going to happen here. You're in for something. So if I take u times v, so that is a times right there. That's multiplication. And I'm going to let this d stand for derivative. So take derivative. What it really is a thing called a differential, which is basically just a derivative. We probably talked about Newton and Leibniz. This was Leibniz's thing. Newton had the derivative, Leibniz had the differential, and they ended up being the same damn thing. No worries. How do you take the derivative of a product? Can somebody tell me? How do I take the derivative of a product of two things? Hint, the answer is in the question. The product rule. Yes, Becky. Stan, yes, exactly. The product rule. I got a product. I want to take the derivative. Here's the product rule. Thank you so much. So that means take the derivative of the u times the v left alone plus the u left alone times the derivative of the v. Right? That's just the product rule. Cool. All right. So I'm going to write that out down here. So duv equals, and I'm going to rewrite some things. So I'm going to write vdu. I'm just changing the order so that d part is at on the right side. Like so, like so. And now I'm just going to integrate both sides. So now integrate. In other words, take the antiderivative. So I'm going to get this. And the integral of the right side is the sum of the integrals. So you can do each piece and add the results and get the same answer. What is, so this here is the antiderivative of the derivative. And they undo each other. So if you take a derivative and then you take the antiderivative, you get back what you started. So this is just u times v. And let's make a little note here that the integral undoes the derivative in some way. I mean, that's kind of that's one of the definitions of integration. And then this stuff over here, we're just going to leave alone, which seems weird, but you'll see why in just a second. And we're almost done with the notice thing here. I'm going to come back up to the top and rewrite this. So I'm going to take this thing and I'm going to write it a little bit different. I'm basically going to subtract this integral v to u off of both sides. So what I get, I'm going to write it in blue because it's the big deal, is that the integral of u dv is u times v minus the integral of v du. This is the big deal for today. You want to tattoo that on your heart. That is, I would write that down. That's how you're going to do every problem in the current web work using this. And I'm going to show you how in the next examples that we do. So this is a little bit of an art here, just like substitution's got a little art to it. You know, what is u going to be? This is also an art. Or it's got some subtleties to it. Let's see, I got some chat going on here. Let me check that out. Oh no, that was just Becky telling me the right answer on some. Cool. So integration by parts formula. I'm just going to rewrite it. And because I want to say it over and over again, the integral of u dv is uv minus integral v du. How am I going to use that? So, example. Let's go back to the thing that motivated this all. So this form is used when we have a product and substitution fails. So we're starting to get like kind of an algorithm. Step one, I got an integral. Step one, substitute, doesn't work. Step two, try integration by parts. So here's the game. The game is this. Choose u to be the part of the product that gets simpler when we differentiate it. In general. and there'll be a couple little cases where that's not going to be the case, but for the most part, it's going to be the case. So let's think about our two parts. Here's our parts. We've got an x and we've got an e to the x. What's the derivative of x? The derivative of x is 1. What's the derivative of e to the x? E to the x. That didn't change. That didn't get simpler, but the x got simpler. So that means this is going to be u. So this got simpler. So we're going to let u equal x. And I would like you to write that out, like literally write out the phrase, let u equal x. And then to the right of that or underneath that, you know, whichever feels best to you, I go to the right. And dv has to be everything else in the integral. So dv is e to the x dx. Everything must be accounted for between u and dv, except for a constant. Any constant you can pull out in front. You don't have to worry about that. But all the variable stuff needs to be either in u or in dv. And that's usually separated by a product. So now, so this is like step one. This is like the setup. And this is where you get the choice. Step two is going to be find du, which is the derivative of u, and then v, which is equal to the antiderivative of dv. So I'm going to rewrite. I'm like writing this out to like give you like a narrative. Hold on, I got chat. Here. Yeah, that is right, John. And you don't need to simplify further. So here we have du is, what's the derivative of x? 1. And then tack on a dx. So always tack on dx. And v is the antiderivative of e to the x. That's just e to the x. And here you're going to lose the dx. When you take that antiderivative, the dx goes away. When you take the derivative, the dx appears. Let me give you a second, write this all down. I see lots of like cranking and writing. That's beautiful. I'm gonna rewrite what we have just so we have a nice clean board. So here's our problem. We let u equal x. We let dv be everything else. Then du was just 1 dx. I'm not writing the 1. You could. It's not. You're not going to hurt anything. You hurt yourself. And then v was e to the x. Then I use the formula. So step 3 is plug these 4 things into the formula. Yeah. So remember this, u dv. This is the part you're given. And we're going to rewrite it. So that left side is that's what helped us choose what u and dv are going to be. So over here, we've got u times v minus integral v du. And that's what I'm going to plug into. And really, I guess you only need, u and v and du. Those are the things you need. So maybe, let's just say that. Let's chain that up. So we just need this stuff here. Just those 3 things. Because dv will go away. We don't need dv after we've identified it. So this is going to be u times v. So u is x. V is e to the x. Minus, and then I rewrite this integral v is equal to e to the x. Du is dx. And this, now I got to do that integral. So the whole purpose of this was to get an integral I could do. And I've got it. Sweet. E to the x. We got that so well. So this is this e to the x minus e to the x. And now I tack on my plus c. So finally add a plus c. Or don't. Have somebody remind you of it. It's not that big a deal. It'll be okay. Nobody's harmed by leaving that off. This is our answer. Let's check. The derivative of that answer should be the original integral, the x e to the x. So I'm going to check, and I'm going to do what Becky said. I'm going to take the product rule on x times e to the x. So let's write out what we need to do. The derivative of x e to the x minus e to the x plus c. Product rule, so I'll put a PR here. Derivative of x times e to the x is the derivative of x, which is 1, times the e to the x left alone, plus the x left alone times the derivative of e to the x, and then minus the derivative of e to the x, which is minus e to the x, and then the plus c goes away, it just dies off, and look at this shit. Those two cancel. Holy smokes. I got it right because I got what I started with. Let me give you a moment to catch your breath. This is, oh shit. Oh man. I freaking, is it coming back? No. It left the Zoom meeting. Did it really? Did I really leave the Zoom meeting? No. I just have to reshare. There we go. Hit the power button on my iPad. Cool. Any questions here at this point? We're going to do a couple together and then call it a day. Because you got like extra kudos for showing up, you know. And you literally get extra credit for having your face on the screen. So that's great. All right, let's do one together. We don't need to see my face twice. Please try this one. So remember, you've got to choose a U and you've got to choose a DV. The U is where your choice comes in. The DV is everything else. This is X times sine of X. I'm going to run to the restroom really quick. I'll be right back. I know that's too much information, but I'm not just getting up and being weird and leaving you. So just make sure we're all on the same page. You want to let u be the x, because that goes to 1. The derivative of sine is cosine. That's not any simpler. It's just different, but it's still a damn trig function. And they're all about the same complexity. So your choice is u is x, dv is sine of x. I'll keep working it out for those that are. Dx. Forgot to tack the dx onto my dv. Be real careful. There's a double negative coming up here. When you do the VDU, you've got a minus in front, and you get a minus from the V. So I pretty much have the full answer up here. And you should check it out, see if we all ended up in the same place. And if not, we should talk about it. And if you don't feel like saying anything out loud, to chat, give me a chat. You can even send me a private chat, so no one else knows but you and me. And I won't say your name, I promise. But let's make sure everybody's on this page. And I will answer any question at all. People are always worried their questions are dumb. They're never dumb. I literally have not seen it. I've been doing this for 30 something years. I've not seen a dumb question yet. How many? I'm curious. How many folks got this? It's like a little fingers stuff. Cool. All right, good. If you didn't, is there anything we can talk about? Anything I can clear up? Any of the steps along the way? Or if you want me to walk through this verbally, I'm happy to do that, but let me know.
The one mistake I had on this was I had a minus sine x at the end because I forgot it was the antiderivative. I thought it was just the regular one.
That's cool. That sounds like I bet you're not the only one who did that, Abraham. Yeah, thanks for sharing that. That's good. That sounds like an easy thing to do. For sure. I could also see like missing this double negative, or maybe just, finding the wrong antiderivative of sine and forgetting it was minus cosine. That could happen. That's a common place for this to go awry.
I have a quick question.
Yes,
When you
Sophie,
took
yeah.
the derivative of cosine,
Yes,
and that became a positive sign, wouldn't that be a negative sign?
it would. So are you, let's make sure, are you talking here?
Yeah.
So I think you did what Abraham did. We're taking the antiderivative here.
Oh,
But you're so right that the derivative of cosine is negative sine, but we're going the other way.
got it. Okay, that makes more sense.
Awesome. Cool.
Okay, thank you.
See, thank you. Hey, friends, just notice 2 people made the same mistake. Same exact mistake. Somebody, if you made a mistake, somebody else made your mistake. This is like the matching game, right? Where you have to remember where things were. Like there's always a match to your mistake.
One quick question. Do you think you could walk through the like taking it backwards to prove it's the same as
Yeah.
the x sine of x?
Absolutely. Absolutely. I would love to. Thanks. Thanks for a chance to do math, Abraham. I'm always happy to do that. So let's do a check. I'm going to take the derivative of this thing. And I'm not going to put the plus c in because we know that's going to go to 0. So I'm going to leave that out. So first off, I got to take the derivative of negative x cosine of x, and that's a product, x times cosine of x. So I'm going to use the product rule on that piece. The derivative of negative x is -1. Leave the cosine alone. Plus, leave the negative x alone. The derivative of cosine, now we got a negative sign because I'm differentiating. So this is just the derivative of this first piece using the product rule. And then I have to take plus the derivative of sine, which is cosine. I'm getting a little tight on space over there. And then simplify. Notice that I've got negative cos x minus x minus sine of x times minus sine of x gives me plus x sine of x. And then I have plus cos. And the coses cancel. And then I'm left with my original buddy. Does that sound good, Abraham? Yeah, and I'm seeing Cam is like nodding and checking that out. And how we feel about that? Does this sound good, friends? Awesome. So hold on. So maybe we could even call it a day because that's a lot. I just want to take a look at the web work that's up and give you some advice on it because I think you can start on it. I just want to make sure. I want to make some recommendations on maybe some problems to just do because some of them we have to still talk about. There's a few things in there that are like what do we do if there's limits on the integral? We haven't talked about that. And then there's some more involved things. So let's see. So you can do problem 1. 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 You can do problem 4. So the web work problems I'm going to recommend you to try before Friday.
It opens at midnight today.
Well, that's not good. I keep getting the damn AM PM wrong. I'll fix that. I'll fix that good. And then
For WebWork 1, or like the first one that was assigned on Monday or maybe last week, that one's due tomorrow, right?
yeah, I think you still have time on that one. Yeah,
Okay.
absolutely. That sounds right. So let's see. So 1, 4, don't do 5 yet. Maybe just 1, 4, and then you could do 9. So number 9. That's it. And it's it's only 10 problem set. So I would recommend by Friday. First off, make sure you finish that first web work. Get 100% on that. Get 100% on all web works, or as close as possible. Sometimes there's this little thing that just drives you nuts and you're just fucking done with it. And that's cool. I get that. But for this one, if you have time, check out 1, 4, and 9. You should be able to knock those out. And if not, I'd love to talk about them on Friday. And we should be in person on Friday. So does this sound good, friends? Yeah, outstanding. Let's call it a day. And unless anybody has stuff to talk about here, happy to hang out and talk to you. But everyone else, Jeremy, you showed up. There's your face. Lovely. Outstanding. All right. All righty, friends. Feel free to leave. Go in peace. Bye.
Thank you, Dr. Trenary.
Thank you. Bye.
Professor, would you be able to answer my question?
Oh, did you type one in here, Gabe?
Yeah.
Let me take a look. Yeah. Sure. Like the formula we're using?
Yeah, like how did you, I guess, get to that formula? Because I think you worked through it, but then, yeah, I just wanted to see how you were able to get to the
Absolutely.
integral of UdV
You got
equals
it.
UV. Yeah.
Okay, cool. So let's take the derivative of u times v first. So that d, just instead of writing d dx or something, I'm using a d to represent take derivative of. So I'm going to use the product rule. So I'm going to take the derivative of the u times the v plus, and then I'm going to leave the u alone, and I'm going to take that times the derivative of the v. Does that step make sense?
Yeah.
Yeah. Okay, cool. So that was the product rule. Now I'm going to take, actually, I'm going to rewrite it one more time. So that's derivative of uv equals v du plus u dv. So all I did there was flip the u and the dv. So now I'm going to integrate. So I'm going to take the integral of all this stuff. Integrate both sides. Does that sound good? Awesome. So on the left side, I've got the integral, the antiderivative of the derivative of something. And that just gives me that something back. So you take a derivative, then take the antiderivative, you're back to where you started. Yeah. And then on the right side, these I'm just going to keep in this form like this. And then the last step is to isolate that term, that integral u dv. So to do that, I subtract this in red from both sides. And I end up with integral u dv, so the thing in blue box, equals u times v minus integral v times du. And that's how I got that formula. I appreciate you wanting to understand that. That's awesome. That's very, yeah, cool. Does it feel a little better now?
Oh yeah, that was really good. Thank you.
Awesome. You got it. Anything else? We good then, Gabe? We're good? Awesome. All righty, friend. I'll see you on Friday. Oh, John, you're still here. Wait. John, do you have a question? Let's see here. Wait. Yeah, you want to see that again, John? That
Yeah, it's just been really kind of bugging me. I've been trying to work on it this whole time, and I don't really know what to do about it.
okay, cool. So we're going to check this here. This is what we want to talk about.
Yeah.
Cool. So first thing, I'm going to take the derivative of x times e to the x. That needs a product rule. So I'm going to take the derivative of the x times the e to the x left alone, plus the x left alone times the derivative of the e to the x. So now I'm done with that piece, minus the derivative of e to the x. And then the derivative of a constant goes to 0. So how does this feel so far?
Oh yeah. I mean,
Yeah.
that works with me.
All right, cool. So the derivative of x is 1 times the e to the x plus the x. Derivative of e to the x is just e to the x. And then minus the derivative of e to the x, which is just e to the x. And so let's just rewrite. Let's get rid of that 1. Notice now that I've got a plus e to the x and a minus e to the x. And so
Yeah.
I'm left. Does that make sense? I end up with that
Yeah.
guy.
Yeah. And then you would just add on the plus c again because of like this would just be to simplify the. Or am I wrong?
Yeah, I would only add on a plus c when I was going the other direction to antiderivative. When I do a derivative, constants go to 0, so we don't mess with those, and we wouldn't tack that on here now. So it's only in the other direction. So like if I look at this statement here, the derivative of that is this. Here's the reverse statement. The antiderivative of e to the x dx is that thing inside the brackets at the top. But
Yeah, and
that's
I think
yeah, go ahead.
yeah, I mean, I kind of get like how to do it backwards and how to get the answer for each of these things. Like, I'm curious because every single time that I do a problem and I come out with a solution, I've gotten the habit of double checking it with like a calculator or something. That way I just kind of have like confidence in my answer.
Mhm.
I don't really do that during class at all, but like I did it just now, like after the previous problem, and I felt like something was wrong. And then it told me that there's a way to simplify this even further. And I don't
Yes.
really get how to get any further. Yeah.
So that's what they did.
I'm just confused because I am really bad with simplifying and I really like need answers. It's kind of my OCD.
Okay, no worries, man. We got you. So notice that there's an e to the x in each of these first two terms.
Yeah.
So I can actually factor that out, and that's what they're doing. So they're saying, look, you can pull that e to the x out. And when I pull it away from the first term, I'm left with an x. And when I pull it away from the second one, I'm left with a -1.
Oh, okay.
Does that make sense?
Yeah.
Yeah, and so you can distribute the e to the x times x, and then the e to the x times -1 and get that answer that we came up with in class. But either one is totally cool.
Okay. Yeah. No, that makes so much more sense. Like that's not a difficult thing to do. I just wasn't seeing it, I guess.
Yeah.
Like I do that thing all the time. So I
Good.
don't know what I was thinking. All right.
Feel better?
I mean, that answered all my questions. So
Awesome.
appreciate it.
Cool. All righty, friend. I think you might have asked that during class and I missed it about simplifying this. So now
Yeah,
I
I
see
think
that
you're.
yeah.
I think you were just trying to move on with the further on because it doesn't really matter for me. Like I've taken the class mostly, so I kind of am ahead in most aspects in terms of like formulas and so forth. So I get that sometimes the questions I have will be going a step further that isn't really needed at this point. So
It's all good. No, it's good. I mean, that's a good thing. There are situations where having it in this form would be advantageous. So
yeah. All right. Well, thank you for class. I will see you on Friday.
yes, sir. Awesome. Thank you. Have a good one. Stay warm.
You too. Bye
All
bye.
right. Bye.